Hello. First, I'm going to go over some of the features of Zoom so that you know how to use them. So let's try sharing the full screen. Okay. Now if I go back. All right. Now here we go. So first I'll go over the chat system. For instance, the chat system is really useful if you want to put up some text in a way that will be accessible in the future. So if you want to propose a discussion question such as what are the costs and benefits of document for education, for instance, you can put it in the chat and it's going to stick around here. So that's useful. Now you can, so screen share is useful because if you want to show work you've done that's electronic, you can put up screen share on the computer. And also Zoom can generate a board. So press new screen share whiteboard. And let's, yes. Now here's a board. So you've got this drawing bar. So you can change the color to whatever you want it to be. And this is useful if you want to talk about the subject like geometry, which is hard to convey in text, but perhaps easier to convey when drawing. So if I want to talk about graphically what the sign of the angle mark theta is, then it's much easier to draw a setup than to try to communicate this in words. And then so there's the eraser for erasing part of the board. So how this works is every time it touches like one stroke, it'll erase that stroke. So this is useful if I've got some intermediate result that I want to save, but I want some space on the board. So if you start something like, and say our utility function is, let's say utility function defined over consumption and leisure is of this functional form. And then you can set up a utility maximization problem subject to some constraint, let's say C plus W L equals W. And then if I decide that, oh, I actually want more space, so maybe I'll erase this old geometry material we're working on so we can make some space for this optimization problem. And alternatively, if you want to quickly get rid of everything on the board, you can hit clear all drawings. Undo is also handy if you think, oh wait, I actually had one last thing I wanted to ask about the triangle before we continue with optimization or the next thing we're doing. And I'm going to demonstrate how you can use the screen share feature to go through material now. So you can grab, for example, lecture slides. So these are some lecture slides on Cournot Competition. So Cournot Competition is an oligopoly model which has multiple firms. And here I'm going to make some assumptions that make the derivation easy: constant marginal cost, linear inverse demand. And they're going to play a game that's Nash and quantities. So each firm chooses a quantity to produce, taking other firms' quantities as given, and prices move to clear the market. And this is a reasonable example for an industry such as the sugar industry, since the products are very close to identical. And it's also reasonable to think about quantities being produced first, and then the firm is trying to market the products at whatever price they can get. And how you think about this problem as a firm is you take the combined output of all the other firms as given. From your perspective, that it doesn't matter the details of how the other firms are producing don't matter. Their combined output is enough of a summary statistic to determine the price. So profits are prices times quantity, that's the revenue minus the costs. And if you simplify this, you can get a first order condition, and this allows you to get an expression for the optimal quantity given firm's perspective. So I'm going to wrap up now.